A sample of helium gas in a flexible container at room temperature exhibits a certain volume. What will be the new volume when the absolute temperature stays the same and the absolute pressure is halved? And this one is actually the exact same question except different way of putting it, no pictures, because in the last example, the pressure was halved. So you can answer this in the same way. The volume of the helium will be double because, again, the numbers on the right-hand side are constant. Pressure decreases. Volume must increase. And to put numbers to that, if the pressure is halved, then the volume must double in order for it to be the same. And this one, you do have to actually choose doubled or quadrupled, so there are choices there. Let's do a different example because I think this is in there too. Let's assume that everything's the same except that temperature doubles. And the question says, what happens to pressure? If volume is constant. Okay, that's another one that's in there. Anybody want to take a stab at this one? If not, let me say, I'm happy to tackle this one too. So temperature doubles, what happens to pressure if volume is constant? Okay, this time volume is constant, moles are constant, and R is constant. So now my pressure, my temperature is increasing. So what has to happen if this is to remain a true statement to my pressure? Now I'll ask you again.
The pressure should double?
Yes, the pressure should double. So I'll just write increasing here so we know that it's increasing. But yes, to make this a true statement, if temperature doubles, then pressure has to double as well. Thank you. Yeah. Okay. Now, and that's because pressure and temperature are proportional to each other. They're on opposite sides of the equation, while pressure and volume are inversely proportional, and they're on the same sides of the equation. Any questions about that? Okay.